Homework 12, section 6.2, combinations in the binomial distribution, video number 1. Excuse me. Before we jump into this section, I need to point out that I intentionally skipped the last section in chapter 5 for the sake of time, thinking that it's not something that we're going to build upon. However, it slipped my mind that there is one small piece of that section that we need in order to do section 6.2 in chapter 6. So I'm going to skip back to the piece that we didn't cover in 5.4. So if you're looking for extra reading on combinations, then I refer you back to chapter 5, section 4 in the textbook. These problems in the homework are linked to that part of the book, so if you click view the textbook from the first 4 problems in homework 12, it will take you to those pages. So let's talk about what a combination is. In probability and statistics, a combination is an arrangement of objects where the order does not matter. For example, let's say that you are going to pick, let's just keep it simple. You're going to pick 4 letters out of this set of letters, A, B, C, and D. And the question is, how many combinations can you make if you select 3 of 4 letters? Now you can only pick a letter once, so you can't pick A, and A. So let's see if we can list the combinations, and then we can answer the question. A combination is just an arrangement of letters, but the order doesn't matter. So we could pick A, B, and C. That's one arrangement of 3 letters where the order doesn't matter. Now, what do I mean by order doesn't matter? Well, that means I can't pick those same 3 letters again, even if I rearrange them. So saying ABC is the same as ACB, it's the same as BAC, it's the same as BCA, it's the same as CAB, it's the same as CBA. So I can't say any of these other 5 variations, or rather permutations, of A, B, and C. Once I say A, B, and C, that covers all of them. These are all the same combination. Now, if you're curious, these are different, what are called permutations, which is an arrangement of objects where order does matter, but we won't be using permutations. So ABC is one combination, and it's the same as all these. So what's another combination of picking 3 of these 4 letters? Well, what if we picked ABD? That's a different combination than this one because it's a different set of objects. And again, I could come up with 5 other permutations of those same letters in different orders, but they would all be considered the same combination. So what's another combination? How about ACD? I don't have that one yet. And there's one more combination that's missing. One more group of 3 letters that's not represented if order doesn't matter. And that's the group BCD. So the answer is there are 4 combinations. Now counting combinations can get a little tricky depending upon how many you're selecting from and how many you're actually selecting. For example, let's say instead of how many combinations you can make if you select 3 out of 4, what if it's only 2 out of 4? And it doesn't really matter what the 4 objects are as long as they're all distinct. Well, let's see if we can do the same thing except only choose 2 of them. Now we're choosing fewer objects, so do you think there would be fewer combinations? Or possibly the same number? Or possibly more combinations? I invite you to pause the video and see how many combinations you can create by choosing 2 of those 4 objects. And remember, order doesn't matter. So if one of your combinations is AB, then you can't also say BA because those are the same groups of letters because the order doesn't matter. So AB is one of them. So pause the video, see if you can find the rest of them. All right, hopefully you paused the video and tried to come up with as many combinations as you can. If you found them all, you should have found more than 4. One of them is AB. another one is AC, and another one is AD. Those are all the two-letter combinations I can make using the letter A. So I can't use the letter A anymore. So let's start with B. BA, wait a second, I've already got that. BC, BD. Those are all the combinations with B. So now we've got all of them that have an A, all of them that have a B, so let's move to C. CA, no, I've already got it. CB, I've got it. CD, don't have that. Now we have all of them that contain a C. Let's find all of them that contain a D. DA, oh, that's already here. DB, oh, that's already here. DC, oh, that's already here. If you counted 6 combinations, you were correct. But let's say instead of picking 2 out of 4, you were picking 3 out of 10. For example, let's say you have 10 people in a class and you have to select 3 of them to receive an award. How many ways could I pick 3 of them to receive an award? Well, you could try listing out all the combinations if we had 10 things and we were picking 3 of them. But, and in my head I'm trying to do the math, 10 times 3 times 4. Good luck listing all 720 combinations. No, I didn't do that right. 10, 3, 4, 120 combinations. Pardon me. It would be 720 permutations. But what did I come up with 120? If I have 10 objects and I'm selecting 3 of them, how can I get the number 120 from that? Well, there's a formula for combinations, and I'm going to show it to you in the next video.